Okay. So, I don't know if I had the camera on when I did this or not. I think I did. I'm sure I did. Okay. The next thing we look at is how these forces might be related, okay? And everybody wants to tell me that this force and this force have to be equal and opposite. And that's right, but it's totally unjustified unless you relate it to Newton's first law. Now, it took us a while. Nobody could really state Newton's first law, and you have to be able to state all three laws clearly, completely. Okay? So look up that statement, but it involves an object moving with constant velocity in a straight line, right? Then you have zero net force, because otherwise you wouldn't have zero net force. Now you can work that out with Newton's first law. Make sure you understand how it says what I'm saying it says. Okay? Equilibrium is that state of motion, which includes a state of rest. Somebody want to tell me it was at rest. Well, in this case, in the y direction, this object is at rest, isn't it? So you do have equilibrium in the y direction. Now, if you have equilibrium, that means your acceleration is?
Zero.
Zero. Means your net force is?
Zero.
Zero. So Newton's first and second law is this, right? Okay, that this force has to be equal and opposite to this force. Okay? Well, this allows us to determine what the normal force is, and if you have friction, that becomes very important for the motion of the object. If you don't have friction, it doesn't make any difference. All that matters is what the mgx is.